Hi, hello everybody. This is our geometric sequence video. So I just like to start off with this. So when we're talking about exponential functions, it's pretty much synonymous. It's like the same thing as geometric sequences. Okay. The only difference is that you can't plug in 1.5 or like 1.4. You can't have those things in between because it's not continuous. It's discrete. All you get is a bunch of points. So you would have seen that today from the activity, is that like arithmetic sequences, if you can remember back to first semester, arithmetic sequences were basically the same thing as linear functions, right? You have a line, but instead now you just have dots that look like a line. Okay, you can't get the parts in between. You can't have 1.5, but in a line you can get everything, 1.1, 1.2, 1.3, all those things, and get something for it. That's why you get a line, because it's a bunch of little points put together that make a line. Instead, you would get point, point, point. So the same thing with geometric. It's no longer a exponential curve. It's going to be an exponential dotting. So here's an example of bacterial growth, and this is something that is relatable to geometric. So if you see right here,
very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
Alright, so if you look at this, right, you start off with 2 bacteria, and then they're going to split off, or you start off with 1, and then doubled into 2, and then into 4, and then into 8. Okay, you aren't able to find like halves of bacteria in this case, because it's a sequence. Okay, alright, so let's go ahead and show you the Chan Academy questions. So here is A and B. I want you guys to take the geometric sequence formula, which is a sub n is equal to a sub 1 parentheses. In most textbooks or online they'll say r, which means ratio, but since we've already kind of called it a b beforehand, we'll use b again. Okay, because you guys should be able to relate it back to exponential functions to the power of n minus 1. So for this one, it should be pretty easy. Put a1 where it should be, b where it should be. And this one, you need to figure out what a1 is. Well, hopefully you guys know that one. And then what's the ratio, or what's happening to this one every time. Okay, what is it multiplying by? Alright, so let me pause the video and then I will continue with the lesson. Alright, so let's look at the sequence 4, 8, 16, 32, 64. Alright, so I'm going to show you this in 2 ways. So I'm going to show you how it looked like if we were thinking of it in exponential function. So this is exponential function. And on the left, I'll think of it in geometric. Alright, so let's start with exponential function. If it was an x and a y, we would have 1, 4. Okay, because the first term gives us 4. And the second one, we would think of it as 8. The third one, 16. Fourth one, 32. And the fifth one would be 64. Alright, so we remember that our b was kind of like, was it doubling, tripling, quadrupling every time. And we can see from here that this is multiplying by 2 every time. Okay, and yeah, it just keeps doing that. Okay, so we know that b is equal to, okay, and I'll leave that there. Alright, so let's go back to geometric. I'm also kind of thinking the same way. Okay, and if you guys need to remember that this is called a sub 1, a sub 2, a sub 3, on and on. So if I'm looking at something like a sub 2, how do I get a sub 2? Well, a sub 2 is equal to, a sub 2 is equal to 4 times 2. A sub 3 is equal to 4 times 2 times 2, right, because it had to multiply twice to get to 16. And a sub 4 would be equal to 4 times 2 times 2, and then one more time it had to multiply by 2, because to get to 32 you would have to multiply by 2 again, right? 1, 2, 3 times. Alright, so now let's kind of think about it, how would this look like, how would this look like, and how this would look like. Okay, alright, so this would change to 4 times 2 to the power of 1. So we know that our n here is 2, right? And this is 1. This one, our n is 3. And if we change it the same way we did above, it'd be 4 times 2 to the second power, right? So instead of 3, it's the second power. And we do this 4, and what do you think the 2 will be to the power of? You got it. It's 3. Okay? Now, if you notice, every time, whatever the n is, it's 1 less. Right? 1 less. What's less? 1 less than 2? 1. Less than 3? 2. 1 less than 4? 3. And that's where this comes from. N minus 1. And that's why we do it for the sequences. Alright, so we can go ahead and put this into its correct form. And I'll do it in green. I'll do it in blue. So we know it's a sub 1. That's right here. That's going to be 4. A sub n equal to 4 parentheses. What's the ratio every time? Times 2 to the power of n minus 1. Once we have that, we can figure out any term. So if I wanted to find the 50th term, I change the n to 50. This changes to 50, but then it'll be 50 minus 1. Okay? And similarly, exponential functions are pretty much the same thing. The only difference is this would be something like, I'll do this one in purple. Y is equal to 2 times 2 to the power of n. And the reason why it's a little different is because this one would have to account for 0 and 2. Because for this one we're always starting at 0. Okay. And it's very similar, but there's still some differences there. It's like the way you're looking at it from like the beginning. Okay, because when we're looking at sequences, we're looking at the first term, which would be like a x equals 1 sort of thing. Whereas in exponential functions, we're looking directly at x equals 0. So it's kind of like looking at it from the left or to the right. And it's kind of like, it's hard to like tell the difference, but they're very similar, but they still have their differences. In exponential functions, you can find things between 4 and 8, right? You can do a 1.5 for the x, right? All you'd have to do is plug this 1.5 into that x. Whereas in this one, you can't necessarily find a term in between 1 and 2. You can't find an a sub 1.5. That doesn't make sense. So the major difference is that sequences is just a bunch of points, whereas an exponential function, you're getting a whole curve out of it. Okay. So hopefully this should be enough. Send me an email if you guys aren't getting it. Hopefully I don't think the homework should be terribly difficult. You just need to find what the first term is, what the ratio or the b is it doubling, tripling, etc., and then just put in the form, and you can find everything after that. Okay. Alright, that's that. Send me an email if you guys have questions. I'll see you guys in class.